Hi guys, good morning everyone. So, in the last class, we are discussing about coordination compounds. In coordination compounds, in the first class, what we discussed number one, introduction about simple salts, double salts, and coordination compounds. Next, we discussed about some important terms used in coordination chemistry, like a ligand, what is ligand, what is coordination polyhedron, other things. Now, in this class, we are going to discuss another important topic named as IUPAC nomenclature of coordination compounds. IUPAC nomenclature of coordination compounds. I'm showing you two worksheets. This is your first worksheet, which contains examples from 1 to 24. So, this worksheet I'm using as classroom worksheet, meaning I'm going to use these examples for my class work, whatever the video I'm doing. I'm going to use examples from this worksheet, and we will be learning the IUPAC nomenclature step by step. Trust me guys, if you don't understand one step also, you can't understand the nomenclature. You cannot understand the nomenclature. So follow each and every step, practice every step, whatever I'm discussing here, right? Yes. So before we start the steps involved in naming, I want to tell you, so this is your worksheet number 2. I'm not going to discuss any questions from this worksheet because this question I'm giving as a assignment. So I'm not posting assignment at the end of the class, I'm posting now itself. So these assignment questions for the next class, you must write or you must solve these questions for nomenclature. Trust me, they're very simple. If you understand, it will be very simple. Okay? Yes. Let's start. So there are 4 simple steps for writing nomenclature of any compound. What are those? Step 1. Know the complex type. Step 2. Know the oxidation state of the metal. Step 3. Know the charge of the ligand. Step 4. Know IUPAC basic rules. Right now, you don't know anything of this, but I'm going to teach you all these steps, then you will understand, you will know things. Okay, let's start. Step 1. Know the complex type. Know the complex type. Complex can be generally a cationic complex or anionic complex or non-ionic complex or a binuclear complex. So what is the meaning of that? Yes, let's see the next slide. You'll understand better. See this. There are 5 examples. We must understand which type of complex is this. Yes. What I do first? I'll do this one first. First example. If you remember, the contents of the square bracket cannot be separated. The contents of the square bracket cannot be separated. Meaning, if I dissolve this in the water, what I get? I get CO NH3 6 times. I'm sorry, this should be 5 actually. So 5, I have Cl square bracket. So plus what I get? I get Cl minus. Cl minus. But how many Cl minus are here? There are 2 Cl minus. So therefore it should be written as 2 Cl minus. Now what is the total charge on this Cl minus total here? This is minus 2. Because this is minus 2 and the whole molecule is neutral, so this cation should carry plus 2 charge. This cation should carry plus 2 charge. Sorry. plus charge. So meaning what? Okay, so this cation carries what charge? Plus charge. So meaning this is complex ion. What is the charge of the complex ion? Okay, so this is plus charge. So this is called as cationic complex. What do you call this? Cationic complex. Now, what do you call this next one? If we do a next one, so you understand here, K will be outside the bracket, so it will divides, it dissociates, K get plus charge. K get plus charge. But how many K are there? 4K. So it become 4K plus. So this is one carrier. What I get other side? Fe, Fe, Cn 6 times should be having what charge? This is total plus 4 charge. This will be now minus 4 charge. Now what do you call this complex type? Yes, it must be called as anionic complex. What do you call this? Anionic complex. Why? Because my complex is anion. My complex is anion. What about this one? The third one. If you see clearly everything in the square bracket, so if you have everything in the square bracket, nothing comes out. So neither cation nor anion. So this is non-ionic complex or neutral complex we call as. So non-ionic complex or neutral complex. Next, what are the fourth one? Fourth one already an anion, right? And this is complex. So it's called as directly called as anionic complex. You don't want to divide it. You can just write as anionic complex. Anionic complex. Fourth one. Then next one, last one. If you see there are two square brackets. One for this, one for this. Okay. Yes. So this is called as binuclear complex because there are two things here. One is cation, one is anion, and both are complex. Both are complex. So we call them as binuclear complex. We don't study much about binuclear complex, so don't worry so much. We'll focus mainly on cationic type, anionic type, and neutral type of complexes. Yes. So let's practice step one. What I want is, I want you guys to choose randomly any one complex you choose, and let's try to find what complex is that. I would choose the example of, okay, what about example 9 I'm doing here. Example 9, question number 9 I'm doing here. Okay, if you see question number 9, so everything is in the square bracket. Everything is in the square bracket, meaning nothing will be ionized, meaning no ions are coming. So this must be a neutral complex. Neutral complex. Guys, one small correction. The 24th question, the square bracket must be after Fe. K3 is outside the square bracket, so please make correction. K3 is outside. So if at all you want to divide the 2 for 24, question number 24 you want to do, So K is outside, cation is simple, and anion is complex. What is the complex? Fe, Cn6, everything you get here. So minus charge you get. So minus 3 plus minus 3. So this is anionic complex. So this is anionic complex. So please do the same thing for all the examples and find out what is the complex type for everything, all 24. Okay, thank you.